On October 2nd, 1991, the Iron Ore Company of Canada shot the largest blast to date in the Western Hemisphere. We've traveled to Labrador City, Newfoundland to meet with Mr. Sadek El Alfi, General Manager of Carroll Mining and Concentrating, and discuss the parameters of the blast, as well as the philosophy behind large-scale blasting.
At IOC, we are committed to achieving an average blast size of 1 million tons. In order to achieve an average of 1 million tons, we need to have much larger blasts. We do that in our firm belief that large blasting improves productivity and reduces maintenance costs on large equipment. The blast was in one of our larger pits, the Humphrey South pit. It was the 4 million ton blast, mostly ore, and it took down an entire bench, which was 800 meters in length, and there was a dog leg on that bench that added another 400 meters. So the effective length of the blast was around 1.2 kilometers. The bench height was 15.5 meters, and the spacing was a square pattern of 8.25 meters by 8.25 meters. It was about 80 to 90 meters wide, and it required the drilling of 1,400 holes. They were 15-inch diameter holes, and these were loaded with MagnaFrac emulsion. We drilled and loaded this blast in a record of 10 weeks. The productivity on the drills was excellent. We kept the two drills on the site without moving them in or out. There was minimal delay times in the drilling. The loading was consistent. We used 2.1 kilotons of explosives, which is almost a subnuclear blast. The product was manufactured here in Labrador City at a plant which is run by ICI Explosives. We used to get up to eight truckloads, each one carrying 9 tons of explosives per day, and that is a lot of explosives for a day. For a large blast like this, the sequencing is critical. If a row of hole goes off before it's supposed to, we can experience cutoffs, and the larger blast in the world could turn out to be the largest nightmare in the world. As you can see from the pictures, the sequencing was perfect, and there were no out-of-sequence problems with this blast. This was achieved through the use of down-the-hole delays and tight control on the initiating procedures. The blast, to put it in perspective, would have taken one shovel 8 months to muck out. You have to realize that our shovels are 700 to 800 tons in weight. They're not really designed to walk very much. When we have a large blast like this, the shovel goes on site and stays on site for several months. And these shovels, their tracks literally melt when you move them out 5,000 feet for a blast and then move them back in again. And they like to stay in one spot for a long time. The benefit is also felt in the drills. From a maintenance perspective, it saves a lot of maintenance dollars. From an operating perspective, it improves the productivity dramatically. By having that big blast, we minimized the oversize, and that was felt in the record cubic meters per hour achieved while we were digging. The oversize is generated at the face of a blast. So when a blast is deeper, you effectively reduce the number of free faces, and as such you reduce the oversize. The fragmentation is excellent. The material reaching the concentrator was also finer and required less grinding. What we've experienced over the past year by going to larger blasts is that we've had less bridging in the loading pockets. In other words, we've managed to increase our throughput through the loading pockets by at least 10%. That is a tremendous number when it's multiplied by the huge volumes that are moved by IOC every year.
2, 1, fire.